Hi everyone, myself Konda Krishnadu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. Today I am going to talk about one of the important topic under the heading called optical fibers. Coming to the overview of today's presentation, today I am going to explain about introduction to optical fibers, after that classification of optical fibers, and then advantages and disadvantages of optical fibers, and finally applications of optical fibers. Now, coming to the introduction, as we discussed in the previous class, optical fibers are very thin flexible dielectric waveguides which are used to transfer information from one place to another place without much loss in energy. So generally they are made of either plastic or glass. Simple structure of optical fiber consists of three layers called core, cladding, and the third layer called coating. And the complicated structure has two more layers, strength member and outer jacket. So generally optical fiber carries information in the form of light. That light will be guided in its middle layer, what is called core. Now, today's our main topic is types of optical fibers. Optical fibers are divided into so many types based on different parameters. The first parameter on which we can divide optical fibers into two is based on the number of modes they support. Based on the number of modes they support. A mode is nothing but the path of light that is traveling in an optical fiber. Based on the modes, optical fibers are divided into single mode and multi-mode optical fibers. Next classification is based on the material used. Based on the material used, optical fibers are divided into glass fibers and plastic fibers. The third important classification is based on the refractive index profile. Based on the refractive index profile, we can divide optical fibers into step index optical fibers and as well as graded index optical fibers. Now, coming to the first classification, which is based on the number of modes that an optical fiber supports. So, just by observing this, we can say that this is an optical fiber consisting of middle layer called core and it is surrounded by cladding. As it is single mode optical fiber, it is allowing only one ray of light to pass through it. Whereas, coming to the diagram on the other side, and it is allowing more than one light of path to pass through it. This is one light of path and this is another light of path, and hence it is called multi-mode optical fiber. Now, based on the material used to make an optical fibers are divided into glass fibers as well as plastic fibers. So generally the basic material used to make glass fiber is silica. The refractive index of silica is 1.45, or particularly it varies between 1.40 to 1.55. Silica is very abundant in nature, so that's why most of the optical fibers are made of glass. Okay, so both glass and plastic optical fibers have their own advantages and disadvantages, but you may get doubt if we make an optical fiber core and cladding using glass. In that case, how to achieve the condition of N1 greater than N2? We know the principle of optical fiber, that is total internal reflection. The basic condition for total internal reflection to take place in an optical fiber is refractive index of the core medium should be greater than refractive index of cladding. So when we use same glass material for both core and cladding, then in that case how to get N1 greater than N2? So there is a simple method. This can be achieved either by adding germanium dioxide to core medium, or we can add B2O3 to cladding medium. So generally germanium dioxide has the capability to lower the refractive index of the material, germanium dioxide has the capability to increase the refractive index of the material, whereas the boron trioxide has the capability to lower the refractive index. So in either of these two cases we can achieve this basic condition which is required for total internal reflection. Coming to the main advantage of glass fiber is that it is very efficient in transmitting data at higher speeds. Whereas coming to the advantages of plastic fiber, they are flexible in handling. They are very easy to handle when compared with glass fibers. Now, the most important classification which we are going to discuss is based on the refractive index profile. So, refractive index, or what is refraction? Refraction is nothing but the bending of light when it is moving from one medium to another medium of different refractive index. When it is moving based on the medium, it will slightly deviate from its straight line path. So, depending upon that, we can say whether that medium is having high refractive index or low refractive index. So, based on the refractive index profile, optical fibers are divided into step index optical fibers and grade index optical fibers. Step index optical fiber. So, what is step index optical fiber? So, the name itself implies that here refractive index of the core will be constant throughout, and when we move from core to cladding boundary, it decreases all of a sudden in the form of a step, and hence the name is given step index. See, this is the graph where we are talking about the variation of refractive index with respect to distance from the center of the optical fiber. The refractive index of the core is constant throughout, whereas it is decreasing all of a sudden in the form of a step when we move from core to cladding. Hence, the name is given step index optical fiber. These optical fibers are divided again into two types: single mode step index optical fiber and multi-mode step index optical fiber. So, now single mode step index optical fiber. The name itself implies that it allows only one mode to pass through it. Since it is single mode optical fiber, its core diameter is small. It is around 8 to 10 micrometers. You can observe here, this is the core medium, and where the refractive index is decreasing all of a sudden in the form of a step. Now, in this case, coming to the signal transmission, it is allowing only one ray of light to pass through it. This is step index single mode optical fiber, and fabrication of single mode step index optical fiber is too expensive, and particularly it is used for long distance communication more than 200 meters, as also in this case the output signal resembles the input signals, and hence there is no problem of intermodal dispersion in this case. Now, multi-mode step index optical fiber. This is the refractive index profile for multi-mode step index optical fiber. This is the diagram through which we can understood how refractive index of the multi-mode step index optical fiber varies with the distance. As we said, the refractive index of the core is constant here, and it is decreasing in the form of a step, and hence the name is given step index. In this case, core diameter will be more. Core diameter is about 20 to 100 micrometers and surrounded by cladding. And as it is a multi-mode optical fiber, it allows more number of light to pass through it. This is one ray of light passing through it, and this is another ray of light passing through it, and one more light ray is passing here. So, like that, it is allowing more number of light paths to pass through it, and hence it is called multi-mode step index optical fiber. In this case, we need to discuss how all these light rays will move. All these light rays will move in the form of zigzag manner, right? Now, we need to remember one statement: velocity of light depends on refractive index of the medium. If the refractive index is same throughout, then velocity of the light beam is also same. In this case, refractive index of the core is same. That's why all these light beams which you are considering are moving with same velocity. Then what happens in this case? Those light beams which makes a lesser distance to reach the other end will take less time to reach, whereas the other light beams will take more time. Particularly if you take this light beam which is moving along the axis, let us take it as fourth one. So, fourth ray of light is moving along the axis. It is making lesser distance to reach the other end, and hence it will move first. After that, the remaining light rays will move. That's why the problem will arise here. That problem is called intermodal dispersion. Intermodal dispersion. So because of this problem, these optical fibers are preferred only for shorter distance communication. Also, they need high power transmission for operation. That's why we need to go for another category, what is called as graded index optical fiber. Now the term is we have to talk about is graded. Graded here is nothing but gradual. So this is refractive index profile, where we need to talk about how refractive index of the graded index optical fiber varies with distance. If you observe clearly here in the middle, refractive index of the core is maximum. As we move from core towards cladding, refractive index is decreasing slowly or gradually. Particularly, it is decreasing in the form of, it is varying like a parabola. At the core axis, refractive index is more. When we move towards core cladding boundary, it is decreasing slowly or gradually. That's why the name is given graded index optical fiber. So in the case of graded index optical fiber, only multimode is available, means it allows more number of light paths to pass through it, and this is signal propagation. Through this, we can say that in this case, light beams moves in the form of helical rays. In the case of multimode graded index optical fiber, light moves in the form of helical rays. Okay, so all these light beams, in this case, one light beam is moving along the axis making lesser distance, but it is moving in the region of high refractive index and hence it moves slow. Whereas the other light beams, they are moving in the region of lesser refractive index. Even though they are making longer distance to move from one end to the other end, they will take same time, and hence all light beams in the multimode graded index optical fiber will reach simultaneously at the other end, and hence the problem which is associated in the previous case, that is called intermodal dispersion, is avoided here. That's why graded index optical fibers are efficient when compared with step index optical fiber in transmitting the information. And this is about the output pulse, and this is input pulse which is moving along the optical fiber. Now, so finally we discussed about the different types of optical fibers based on different categories. Finally, which optical fiber is preferred for longer distance communication? The answer is single mode optical fiber. Single mode optical fiber, it is less prone to interference while it is moving, and also it is transmitted at higher bandwidth, which will carry more information. That's why single mode optical fibers are preferred over multimode optical fibers. Now coming to the advantages and disadvantages of optical fibers. As we discussed earlier, the attenuation or losses are minimized to a great extent in this case, in the case of optical fibers, when we compared with conventional cables like copper cables, and they are made of either plastic or glass. That's why they are less prone to electromagnetic interference while they are moving from one place to another place in the environment or atmosphere, and they are smaller in size, and they will carry more information because they are carrying information in the form of light. And these are the advantages. Even they have some disadvantages, and their cost is more when compared with the conventional cables, and operating optical fibers need a special training, means careful handling is required while using optical fibers. Finally, applications. Optical fibers have so many applications. They have vast amount of application in different fields. In medical industry, they are used as endoscopes to study about internal organs of human body. And next, they are very much reliable. The leakage of information is avoided in the case of optical fibers. That's why they are used in defense. They are used in defense like sonar, aviation, and they are used in seismic applications also. And they are used in communication, where they are used to transfer more information when compared with conventional copper cables. And finally, they are used in household for lighting and decoration. So like that, optical fibers have so many applications. Today what we discussed is about different types of optical fibers based on different parameters, single mode and multi-mode based on the number of modes of propagation, glass fibers and plastic fibers based on the material used to make, and finally step index and gate index optical fibers based on the refractive index profile. And also we came to know which optical fiber is preferred for longer distance communication along with advantages, disadvantages and applications. Now that's all for today, and in the next class we are going to discuss about the very important topic about optical fibers, that is numerical aperture and acceptance angle, where we are going to discuss about the definition as well as the derivation for these two. Thank you.